Choosing a carbon fiber chassis over a steel one is usually done to improve vehicle performance through lightweighting. A lighter vehicle leads to more efficient fuel or battery use. The implication then is that a carbon fiber chassis is more sustainable than a steel one. The question is, do the benefits of lightweighting in this way actually outweigh the very high embodied energy of carbon fiber? Using the Eco-Audit tool in Granta Selector, we can do a very high level and very quick comparison of both chassis and see and make some conclusions which you can add into your presentation for the competition. Now, if you've never used the Eco-Audit tool in Granta Selector, here's a video showing you just how to do that. In Eco-Audit, we'll name a new product, the space frame. Now we're only looking at the embodied energy for these chassis, so we're only going to consider the materials and the manufacturing processes. Under materials, we'll name our component chassis, and the material we pull from the Granta Selector database. I'm going to find it here under metals, ferrous metals, carbon steels, medium high carbon. It's the 1040, this one over here, annealed. And just double click to add that into the Eco-Audit. We're saying there's no recycled content for this particular space frame. The mass, we've taken this from the CAD model, and that was 84 kilograms. Primary process, roll forming. Secondary process, we're saying here is cutting and trimming. And for this, about 10% will be removed. We're estimating here, just to give an idea of the energy required. At the end of its life, there are different options, but we're going to say that this space frame will be recycled, and 100% of that will be recovered. When it comes to joining and finishing, we can add some more processes. For instance, a joining process. I'll just type in the name there. There are a few options here. We'll think about welding, and the total amount of area welded, we'll just say it's 0.1 meters. We won't consider transport or the use because, once again, we're only looking at the embodied energy. So that's the first chassis done. We're going to try and look at the monokok now. To do that, we're going to go to compare with, make a new product, and name our product monokok. Under material and manufacture, we'll do the same thing. Component is once again the chassis. The material we're pulling from the database. And this time we're going to go under hybrids, composites, polymer matrix, epoxy, carbon fiber, the unidirectional prepreg, and double click once again to add it into the Eco-Audit. No recycled content. The mass, we've estimated this from CAD drawings, from papers, to be about 24 kilograms. It may vary depending on your particular chassis. Primary process, compression molding. Secondary process, I'll just take this chart out of the way. We'll say cutting and trimming, and once again, about 10% removed. The only viable option for a carbon fiber right now is landfill. So we'll keep that here. And recovered, well, none of that is recovered. We'll also include the honeycomb part of the monokok chassis. So for that, we'll just name this honeycomb. And we'll pull in the material. So it's a hybrid material under honeycombs here. Expanded, longitudinal direction, aluminium, 3003, and this is the one we want. Once again, no recycled content. We're saying for this one, the mass we've estimated to be about 4 kilograms. Primary process. For the primary process of the aluminium honeycomb, there's nothing specified here, but you can add in your own custom process information. For this, I've taken from the database an extrusion process for another aluminium. So I'm just going to call this AL3004 process. The process energy, I got this from the database, is 3.3 millijoules per kilogram, and the CO2 footprint is specified as about 0.25 kilograms per kilogram. Secondary process, once again, cutting and trimming, and we'll say 10% removed. In this case, we can possibly recycle this, or maybe reuse it since it's already bonded to the carbon fiber. recovered 100%. For joining and finishing, we can include a process like adhesives. And from the drop-down list, we can find adhesives here. Perhaps heat curing. The amount, this is taken from the total surface area that was calculated from the CAD model, and about 5 meters squared. And that's it. We have our materials and our processes for both our chassis. To compare them, I'm going to click on Summary Chart, and we can see them side by side. From the material selection in the previous sections, we know that both the space frame and the monokok will satisfy our design selection criteria. However, if you're interested in looking at the sustainability and the environmental impact of your decision, carbon fiber chassis greatly outweighs that of the steel. So is there an alternative? Is there another option we can try? In the material selection for the monokok, not only were carbon fibers highlighted as materials that would work, glass fibers were highlighted as well. We can do a comparison and include glass fiber composites and see how they fare compared to the space frame made of steel and the monokok made of carbon fiber. To make a comparison with the glass fiber, I'm going to go to compare with and make a copy of the current product. So we'll have 2 monokok chassis. I'll just get this out of the way. I'll name this new one. I'll just add in glass fiber so we can tell the difference. And all I'm going to do is update the material here to the glass fiber and also update the mass to account for the slightly higher density of the glass fiber than the carbon fiber. We'll pull the material from the database as usual. And under polymer, we don't want epoxy this time. We want the polyester. And under polyester, woven fabric. And we want this one, the 65% weight glass biaxial layup. Double click to add that into the Eco-Audit. From the data sheet in Granta Selector, you can see that the polyester glass fiber is about 20% more dense than the carbon fiber. So we'll update the mass to reflect that and put 29 kilograms here. And that's it. That's all we need to do here. If I go back to our summary chart, we can see the difference. Here's the space frame made from steel. Here is our monokok made from carbon fiber. And here is the one made from glass fiber. All of these fulfill our design requirements. However, all of them have very different impacts on the environment.